Hey everyone. Really glad to be talking to you all at MongoDB Local today. Now that we've kind of covered a lot of the basics of, RAG, let's actually go ahead and implement this using a lot of the tools that we discussed earlier in the talk. So to do this, we'll be using a few key parts of LangChain ecosystem, along with MongoDB Atlas and the OpenAI API. So the LangChain tools we'll be using are LangChain templates. We have like a nice template with Mongo that kind of bootstraps a lot of this. We'll also be using LangServe, which provisions a API server for you using kind of like our expression language. And then we'll be taking a look at LangSmith to kind of see how you can debug and actually look into the documents that you're retrieving. So first things first is we actually want to set up our DB. So here I've already kind of set up a DB in MongoDB Atlas, but I'll create a new collection that will actually be ingesting into. So let's go ahead and create a collection. And as part of this collection, and like one of the key things that a vector store really unlocks is we'll kind of want to set up this search index. And so in the tutorial, we already have kind of the basic setup for this, but you want to go to your DB and actually create this search index. And what we're really doing here is telling it to perform cosine similarity search on the embedding field. And so this is something we'll use in both ingestion and retrieval. And this is really kind of like the core power of like a vector DB. And we'll want this on the documents DB. Cool. So now that we've kind of set this up, let's actually go and look at some of this code. So I've already bootstrapped a lot of the code. In the template, it'll kind of show you how you can run LangChain in it and get a lot of this code by default. The main thing that we're really going to want to do here is set up our environment variables and things like that. So my collection name is actually documents, and we'll want to make sure this is the same in both our chain and in our ingestion pipeline. So I'll just call this documents. Cool. And so now let's take an actual look at this ingestion code. So our ingestion code here is super basic. We're just going to be loading a PDF. This PDF is basically a paper. It's like a GPT-4 technical report. It's just a very long paper to kind of show how chunking and things might work. The next thing we're going to do is going to split this up into smaller chunks because we can't really search over the whole DB. That's not really going to work, and it's not going to really provide us anything super valuable. This is also like a parameter that you're probably going to have to tune when working with your own RAG pipeline. But for now, we'll just use some same defaults, and these are pretty common. And then finally, we'll actually upload these to our DB and store the embeddings. We'll be using the OpenAI embeddings class for this. So let's go ahead and actually run this. This might take a little bit, so I'll probably skip that, and we'll go and see the documents in the DB. Cool. So now that our ingestion pipeline is kind of run, you can kind of see that in our collection we have all these cool documents, and so inside these documents we have our embeddings. This is probably not that useful to you. And then we actually also have the text, and this is really what we want to be, feeding the LLM as part of our retrieval and generation component. So now let's actually kind of look at how that might look. So once again, we're kind of using a lot of the code that's provided to us by the template. We're also using the MongoDB partner package again. So here we are, just initializing it as a vector store. We also have some kind of basic cleaning of the docs. You'll probably want to tune this again based off of the docs that you're actually working with. And then the one part that I really want to dig into is actually this prompt template. And this is a very common kind of RAG prompt. And essentially what it's saying is it's just trying to stuff a bunch of context into the prompt that we're passing the LLM. And so this context is really where we take the external data that we're retrieving from our vector store and passing it to the LLM. And then naturally, we also want to pass in the question, so that the LLM can actually answer the question at the end of the day. We'll also be, calling chat OpenAI, and then we'll be building this chain that uses all these components. So what we're going to do first is, retrieve using the question that we're asking. Then we're going to pass the question and context into the prompt. We're going to pass that stuffed prompt into the model, get a generation, and then we're going to parse the output and then handle some callbacks. So now we have this chain that's really cool. But let's actually kind of dig in and try to run it. So one of the really nice things that LangChain provides for us is LangServe. And so LangServe is basically a way to add your chains to any fast API server. So all I need to do here is import this add routes, and then I can copy that chain that I had. So cool. So now that we've kind of got everything set up and we have our LangServe, fast API server, let's actually kind of run this and interact with our chain and see how that goes. So once again, we're using a LangChain CLI. So we have this nice LangChain serve command. This will just spin up the fast API server with those RAG Mongo routes that I was talking about earlier. I think one of the really key ones that we want to dig into is this playground. And this will give us a UI that allows us to easily, for lack of a better term, play with our chain and ask it questions and things like that. So let's go to the URL. And let's actually ask it a question. So the report that we digested was on GPT-4. So let's ask it a question on GPT-4 and see how that performs. One of the other things I've also done as part of this is set up kind of LangSmith tracing. And what this will do is it will actually take all the different steps that our chain is taking and make spans for it. And we'll take a look at the UI of how this looks, but this will help us debug and analyze the chain that we're running. So let's ask it a question about GPT-4. What are limitations of? Cool. So this response looks pretty sane. But how do we know our retrieval is actually working? So let's go ahead and dig into LangSmith. So cool. You can see this trace that just ran. And these are all the different steps that I showed in the chain earlier. So the main thing that we really want to look into is that runnable parallel / retriever step. And as you can see, there's these top 5 documents. All of these documents look pretty correct. We were asking about limitations, and these look like pretty high value items to me. We can also see how these were shoved into the question and kind of see all the different context that's being added to the prompt. This is all passed into our LLM, and then we get that output that we were interested in. So as you can see, our retrieval is actually working pretty decently. I think you'll find that when you're working with more complex examples, you probably have to do a lot more tuning. That's where LangSmith can be really helpful, as well as kind of some of our evaluation features and things, because you really, there's a lot of hyperparameters that you'll need to take into account when actually building a pipeline in production. Yeah, well, thanks everyone for joining me today. This is our basic RAG pipeline. We spun this up pretty quickly. I'd love to see how you guys use this. Hopefully, this was educational for you. And if you do end up using LangChain for anything, please feel free to tweet us. We'd love to learn more and see what you're building.